What is cohesion here? It measures the relative function strength of a module. Methodology or a strategy we have in order to do the designing, bottom up as well as top down. Structured analysis will going to help the analyst to understand how the system will going to work, and all the activities whatever we have in the logical way, everything will going to be showcased. If it is satisfying a particular or a stable user requirement, then it won't be able to work with flexible system. Hello everybody, a warm welcome to one and all. Welcome back to the session 2 of Unit 3 B.C.A 6th semester subject called Software Engineering. I am Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So as we all know that we are in the Unit 3, that is Design Concepts and Coding. So before getting into our today's session, we'll just see the recap of my previous session. In the previous session of this unit, we have discussed regarding what is software design principles. So mainly to reduce the complexity of a designing of a software, we are going to have this software design principles. Under that we have 4 kinds. So problem needs to be partitioned and abstraction needs to be maintained, and also we have a modularity. Along with that we have a design approach. It can be a top down approach or a bottom up approach. So by making use of all those 4 elements of this software design principle, we can reduce the complexity of development of a software, and also it will reduce us the number of errors. So in our previous session we have learned regarding how we are supposed to do the problem partitioning, and along with that I have discussed regarding abstraction. So there can be function abstraction or can be data abstraction, and also we have a modularity. So this is what I have discussed in my previous class. So in our today's session we are going to see about what do you mean by modular design. So now we got to know that regarding this modularity, how modularity will going to work, then how this modular design will going to work. Along with that, what are the strategies we have for doing that designing. So that can be either top down approach or a bottom up approach that I will be discussing. Along with that, at last we'll see the difference between structured and object oriented analysis. Is like a difference between POP and OOP, that is object oriented programming or analysis, and also we have a procedural oriented, that is also considered as what structured oriented analysis. So in short, that is SOA and this is object oriented analysis. This is what I will be discussing in my today's session. We'll see the first topic, that is regarding modular design. So why this modular designing is important, why we need to design the modules, that you can see here, mainly in order to reduce the design complexity. So just imagine we have a large module or I have a complex module. I wanted to, when we are using this modularity approach, at the time we are going to use a divide and conquer methodology, right? So this will going to allow us to divide the complex module into number of sub-modules. Then we are going to find the solution of each sub-modules. At last we will going to integrate all the sub-module solution to get the solution for the complex module. That is what we have to do here. So when we are having this modular design, at the time this will going to help us in order to reduce the complexity at the time of its designing, and when we are reducing this complexity, at the time it will going to helpful in order to make that as a easier and faster implementation by the parallel development of various parts of a system. So just imagine I have one module here. So that module will going to be divided into number of modules M1, M2, M3, so on like this, right? So each module will going to perform its own task. So when I am integrating all the modules together, we can make use of a parallel programming, or else it will going to helpful for the parallel development. So when we have this serializability, or when it needs to be done one by one or in a linear manner, at the time first I need to finish up with a M1 or a module 1. If it is done, then only I can move to the M2, and after that then M3. But when we are having this modularity, at the time parallel development will going to be takes place. At a time, all the modules are getting designed, so that by integrating all these model, we can get the solution for the main module. This is what the main thought regarding this modular design. So in this modular design concept, first we have a functional independence. So when we are designing any of the modular with a modularity, at that time it will be a functional independence. So why I am saying this, already you know about the function. These are the methodologies. We are going to write a set of lines of code in order to perform a particular task, and each task should be isolated from another task. For example, if I am doing anything with respect to this M1 module, that should not affect the M2, or it should not get affected by M2. That is what isolation that needs to be maintained here. So when we have this functional independent, it is not depending on any other function. It will going to have its own purpose, and it will going to do its own task. So that functional independence is achieved by developing the functions that performs only one kind of task and do not excessively interact with other modules. So this is what, just do your work. That is what here. So this M1 will going to be prepared, or this modularity will going to be takes place in order to have its own function. It won't bother what M2 is doing, what M3 is doing. So instead of that, it will just focus on performing only one kind of task. So for that reason, we are making it as modular, and it will going to be stored in the library. So when we wish to have for a particular reason, or for particular purpose, at the time we can just include that. For that reason, it will going to perform only one kind of task, and it will not going to interact with any other modules with respect to the function. So then we can say that as a functional independence. So next what we have here, that is independence is important. So why we have to maintain a independence in the function? Mainly this will going to make the implementation more accessible and faster. So if I just wanted to take M2 or M4, then I don't need to bother about M1 and M3. Why? Because M1 is not depending on M2, or M2 is not depending on M3, M3 is not depending on M4. I just wanted to take M2 and M4. So at the time it will be easy for the accessing, and also it will be faster. So when it is having its own purpose, or when it is developed in order to perform a particular task, at the time this will going to be very helpful. So when we have this functional independence, this will going to have certain advantages. What are those? We'll see. It will be easier to maintain. So if we have a different models, it will be easy for the maintenance and mainly for the testing. So all those will going to be done a testing in the terms of unit testing. At last it will be like system testing. So individual for testing is also easy, for maintenance purpose also easy. And if it is all those easy, then it will be going to reduce the error propagation. The number of errors will going to be less, because it's not dependent on any other models. If you are getting any errors in the M2, if M1 is depending on M2, at the time that M2's errors is also going to affect on the M1. When there is an independence of a function, at the time error propagation will be less and can be reused in other programs as well. So if I wanted to use M1 in program 1, or if I wanted to use M2 in program 2, we can reuse it. So that is what the main advantage. And also this function independence is a good design features, and we are going to ensure the software quality. So when we are doing it in a module wise, or when it is divided into certain modules, at the time each module will going to be developed, compiled, tested, everything will going to be done individually. So that focus, or whatever the attention that we are paying for a particular module will going to be very high, and risk will be very less, and number of error propagation is also less. So by saying that, with the help of this program or a functional independence, it will going to help us in order to build a quality software. And how we are going to measure this independence, or how we are going to measure the software quality, that too with the help of these two criteria. One is cohesion and another one is coupling. Very, very important topic. What is cohesion and what is coupling? For 2 marks, or you can expect functional independence or modular design for 10 mark or 5 mark question also. Moreover, this topic is very, very important. This cohesion and coupling definition you should never forget. That is what here. So already I told you, right, we have a module. In that module, I have certain modules that will going to be divided into M1, and here we have a M2, then let me take M3, as well as we have M4, right? So now you see the definition of this cohesion and coupling. What is cohesion here? It measures the relative function strength of a module. This mainly specifies the independence of each module. How one module or a module 1 is independent and how potential it is in order to satisfy the requirement of a customer. That is what M1. So it mainly specifies its functional strength of a particular module. We are not bothering in the cohesion how it is going to communicate with M2 or M3 or M4. Mainly we are concentrating on the strength of this M1 independently. That is what cohesion, that specifies the potential or a strength or a function strength of each module. Next, what we have here? Coupling. So as the name indicates, coupling in the sense what? It measures the relative interdependence among the modules. So here, how this M1 is going to be dependent on this M2 and how this M2 is depending on the M3. So you may ask me, right? So already you told it's of function independence, but here you are saying in the coupling it has an interdependence. Why? Because in the modules, each module will going to be interdependent, but each will going to perform its own task. So in order to, when I wanted to integrate these two, at the time interdependence or compatibility should be there. For that reason, we have this coupling methodology. So this criteria will going to measures the relative interdependence, how potentially it will going to depends on other. So how this M1 is potential on its individual, and if I am combining M1 with M2, how compatible it is and how it will going to be interdependence of each module will going to be described in the terms of coupling. So these two are very, very important. So now we got to know that functional independence. Then why we need to hide the information? That is information hiding here. So why hiding of information is necessary? So if you are running a business, will you be ready in order to showcase all your confidential data to everybody or to every stakeholders? Somehow no, right? So the information hiding is necessary in the development or designing of the modules also. So why? Because you can see here. So mainly this information hiding will going to suggest the modules can be categorized by the design decision that protect from others. So whatever the decision we are making, if you want it to be unique in a market, then you should have your own strategies. You should not showcase your confidentiality to your competitors, isn't it? So in this also, it needs to be characterized by the design decision. So how it needs to be designed? What are the unique way of designing we have? So all those design decisions should be protected from others, those who are not authenticated user or authorized users. And also it will going to should be specified that data included within a module is inaccessible to other modules and that do not need for such information. So for example, I have 4 modules in my module, okay, M1, M2, M3, M4. But what is M1 is doing? That should not be disclosed to M2. What M2 is doing? That information or a data, whatever we are using, that should not be disclosed to M3. So when we are maintaining the hiding of that information, this will going to be helpful in order to make a best decision design. That is what the reason information hiding should be there, mainly in order to make a strategic decision of design. And also this will going to helpful in order to save the data or maintain the confidentiality of a data, whatever we have in the particular modules, and should be accessible only by the authorized user. So next, why we need to have this information hiding? Mainly for the design criteria for modular system that will going to provide the more significant benefits. So when the modifications are required during the testings and later during the software maintenance. So if you are showcasing, so why we require showrooms? For any of the devices, we require showroom or else we require garage. Also for some repairs, we require that repair shop. So why? Because we don't know how to repair it. So they are not disclosing their confidentiality, how to do that. They are not showcasing us. So if we know everything to repair all the gadgets, then we won't go out of the house in order to get it repaired. So that's what information hiding is required. So when modification is required, so if you wanted to modify any of the electronic gadget, at the time we usually go to shops. Why? Because we don't know how to do it, and we also have certain fear, if I'm doing this, what will going to happen to this electronic gadgets, right? So when we wanted to do the modification at the time, and when I wanted to test that, or if I wanted to integrate it with other, and if we are disclosing every confidential data about the modeling or what data of that particular model, then it will not going to satisfy the security or a quality of a software. You should not disclose the information for the unauthenticated user. So in order to maintain the software quality, that information hiding is also going to be very important, so that at the time of modification or at the time of testing all those modules, and also at the time of maintenance, this information hiding will going to surely help in order to improve the quality of a software, so that most of the data and procedures are hidden from other parts of the software. Mainly, inadvertent errors introduced during the modifications are less likely to propagate to different locations within the software. So if you don't know what is the errors in M2, and if I don't know what is the errors in M1, at the time we won't bother it. So I will just focus on the errors of M1 other than M2. So but when I come to the M2, at the time I will focus on the M2 rather than this M1. So when we are hiding the data, or when we are hiding the information from one other models, at the time the quality will going to be very more. So all these are related to information hiding. So now we'll see about the strategy of design. So now we have to do the designing. So you have to create unique design from other models. Then how we are going to do that? Why this strategy should be used for the designing? So in order to make a development easy, or to designing easy, and also if you wish to change the design in the later state, at the time the strategy will going to help us, mainly in order to change or in order to do the easy development. And also here the structured design methods help the developers to deal with the size and complexity of the programs. So there also we have this structured design. So we have a structured design, object oriented design. So when we have the structured oriented design or a structured design, that will going to help the developers. So after designing, developer has to develop, right? So they have to start implementing. So that will going to help the developer to deal with the size and complexity of the program. So mainly it will specifies the time and complexity of a program. If it is increasing, then the complexity is also going to be increased. So it needs to be maintained. So that is what structure design here. And this analyst, already you know about this analyst, right? And you know its roles and responsibility in the SDLC or a software development life cycle. So he is the person, one who is going to develop, or one who is going to analyze what needs to be developed and how it needs to be integrated, when it should be used, how it should be used, why it should be used. All the WH questions will going to be answered by this analyst. So here we have two strategies or two possible approaches we have in order to do the strategy of design, in order to maintain or to incorporate the strategy in a design. So it can be top-down approach, and also we have a bottom-up approach. It's like what? Hotel menu and catering. For example, when you visit a hotel, at the time certain a specified set of food will be there, food menu will be there. So if you are selecting any of the South Thali or North Indian Thali, at the time, so you need to take whatever the food is available there. But when you go for the catering, at the time there will be a list, and based on your wish you can pick it up. That is what bottom up, and hotel is the example for top down. Let me tell you about this top down approach right now. So in this top-down approach, mainly is what we are doing everything, all these design strategies we are using to reduce the complexity. That is what. So in the top-down approach, what will going to be done? So module will going to be divided into number of sub modules, and each module will going to give certain resultant. That is what in the top down approach. So in the level 1 complexity will be high. When it reaches to the level 2, somehow complexity will going to be reduced. When it reaches to the level 3, again the complexity will be minimized here. So that in the top down approach, it starts with identification of the main component. So here this is my main component, right? So if I get to know which is the main component, that needs to be decomposed or it needs to be divided, at last we are going to conquer it. Then decomposing them into their more detailed sub-component. So all these are the sub-component. This is the main module or a main component. So when we are dividing it into sub-modules or a sub-component, at that time the complexity somehow will going to be reduced. This is top-down. What if it is inverted? That is what? Bottom-up approach. Already we have certain developed modules. Based on my requirement, I have to choose it and I need to get a solution for my complex task. This is inverted tree. So that is what? Bottom-up approach. So this begins with the lower details. So here no much details will be there, right? So you need to pick it up all the modules in order to satisfy the requirement of yours, so that it will going to have a lower details and moves towards up the hierarchy. And this approach mainly will going to be useful for the existing system. So when you wanted to maintain, or if you wanted to have any other utilities for your system, you wanted to have a add-on, so at that time you can go with bottom-up approach to enhance the efficiency or effectiveness of a system. These are the different methodology or a strategy we have in order to do the designing, bottom-up as well as top-down. So next, we'll see the difference between structured and object-oriented analysis. Already I told you regarding structured analysis, right? So there it will mainly focuses on the procedure rather than data. For example, 2 plus 3. So what it is? I wanted to add two numbers, that is 2 plus 3. So when we have the structured analysis, at the time it will going to focus us on how to do this addition. They won't bothering what we are adding. Instead of that, they are focusing on how to do the addition. But in the object-oriented analysis, there we are going to focus is on the data rather than procedure. First, I need to focus what I am supposed to add instead of how to add. That is what the difference between what a structured analysis and object-oriented analysis. So mainly, analysis is simple. That will going to be done by the analyst to make it easy. That is what here. So mainly we are studying or we are examining the structure of some elements of a development system, and also we are going to specify all the system requirements in detail and methodological way. So how it needs to be, what we are using and how it should be used, all those will going to be specified when we are doing this analysis. So here I should not neglect either structured method or object oriented method. So if you consider both of them, the structured analysis is somehow older. So we are not using that. Why? Because it's of what some static way of doing the analysis is there in the structured, but object oriented is not like that. It's spontaneous and it's flexible. So that, but both are important. So now you can see the difference between those two. We'll see the first one, that is structured analysis. You're already familiar with the programming language called C, isn't it? So in the C programming languages, if I wanted to use any of the variable, that needs to be declared first, then I can use it in the main function, isn't it? So that is what structured analysis. So this comes under top-down approach. First we have a main function. Within the main function, I need to declare a variables. But what about C++ programming language? If you go with the classes and object concept, there I can use all the variables, then I can have the main function. There we are going to create an object. So that is bottom-up approach. For the designing purpose, we require top-down approach. For the implementation, we require bottom-up approach. That's why we require both the strategies, and somehow one or other strategies are interdependent on each other. By making use of those two, we can develop or to design the best software here. So we'll see about the structured analysis now. So it's a method of development that allows and gives the permission to the analyst mainly to understand and know about the system and all its activities in a logical way. Structured analysis will going to help the analyst to understand how this system will going to work, and all the activities whatever we have in the logical way, everything will going to be showcased. Already I told you 2 plus 3. So there my concern is regarding how to do the addition. So I am performing the activities. All those information will be given to the analyst, and also it's a simply graphic that is used to specify the presentation of the application, how this application is working and what are the activities it is taking place. All the information will be given to the analyst. There is no hide and seek here. All the information will going to be available for them. So now here you can see the example for this structured analysis, right? So what it comprises of, it will going to have different state, and that state needs to be transmitted, or transition has to takes place from one state to another state when the certain event is occurring here. So that account application will be given by the customer to the bank. So they are going to create a new bank account with no balance. As of now, when they are creating a new account, then there will be no balance. After that, if the customer wanted to make a purchase, then they have to make the account active, then need to have certain balance. So if they have certain balance and customer can make the purchase. So after that, customer needs to pay the bill whatever they have purchased. So if the customer done with the purchase and all, they wanted to close their account. At the time, customer will going to request to close the account and they pays the balance. At that time, this will going to be closed. Account will going to be closed and no balance will be there. Everything is cleared from the customer. What if the customer is unable to pay the bills? At that time, customer does not pay his bill, then it will be considered as what? Bad debt account balance. So this is how one state is transmitting from one state to another state when certain event is occur. So when they are able to pay the bill, at that time customer can make one more purchase. So if they are not able to make, at the time that will comes under bad debt. If they wanted to close, then this will going to happen. So all these states are changing from one state to another state when certain event is occurring. This is how we are going to call that as a state transition diagram, and this comes under structured analysis. We'll see the next type, that is regarding object oriented analysis. What about this object oriented analysis? So here everything will be considered in the terms of object, right? For example, if I can consider this as an object, yes. So if it is having certain characteristics and it is performing some of the operation, then it will be a real world entity. I can consider this as an object itself. So in the object oriented analysis, it's a technical approach. Generally, when we are going to use it for analyzing and application designing, and also we can use this object oriented analysis in the system design or even for the business designing by making use of the object oriented programming language. That is what you can have C++, Java, Python, all those are the object oriented programming languages, and it is following the bottom up approach for the implementation. For the designing, we are going to use top down. For the implementation, bottom up approach. So mainly it will going to be helpful in order to analyze and in order to design the application and system design or even business design. Along with that, we can use some of the object oriented programming language. Along with that, we can make use of this visual modeling in order to process the development, in order to make it easy for the stakeholders, and how stakeholders is communicating with each other to the developer or a designer to specify their requirements. This object oriented analysis will going to improve the quality of a product by letting the stakeholders to communicate with a designer. So with the help of programming language or object oriented programming language, we can design and analyze the system, business, as well as we can also design the application. And also, this is a process of discovering where a team of development understands and models all the requirements of the system. So here, by communicating with the stakeholders, they will be able to understand what are the requirement, and by understanding their requirement, they are going to models all the requirements of the system. So here you can see one of the example. So here user wanted to create their account, if the creating of account is pending, then it can be approved or rejected, right? If it is approved, then the account will going to be activated. If it is rejected, then it will going to be deactivated and they are going to do the deletion of that user. So if it is in active state and if the user wanted to activate or to deactivate, that can be takes place. So mainly what it is focusing on, it's focusing on the data rather than the procedure. So that is what in the object oriented analysis. So now you can see the difference between object oriented as well as the structured analysis. So when it comes to the C programming, that comes under structured analysis. When we have a C++, Java, all those comes under object oriented. First we'll see. It mainly focuses on the process and procedure of the system, how to do the addition. Instead of that, what we are adding. So in the object oriented programming or analysis, it focuses on the data or it focuses on the real world object rather than how to do the process. So in the structured analysis, system development life cycle, that is what SDLC, that comprises of what? Planning will be there, analyzing and designing, implementation, supporting an information system. But when it comes to this, it will going to use this incremental or iterative methodology. Already it's available. So I just wanted to add on certain new features to the existing system. So there it will going to use incremental or iterative methodology in order to refine or to extend our design. And next, it's suitable for well-defined projects with stable user requirements. Already I told you, if it is structure, that is of static requirements design. So when we have a static or when we have a stable user requirement which is not going to be changed again and again, then we can go with this structured analysis. But if I wanted to change it spontaneously or flexibility should be there, then we have to use this object oriented. So here it will be suitable for the large project with changing user requirements. Very, very important. So when the requirements of user is getting changed, then we have to use this object oriented analysis. Then risk while using this analysis technique is high and reusability is also low. So here it is of static methodology and stable user requirements can be implemented with the help of this, so that analysis technique is somehow will going to be high risk. Along with that, it will going to have a less reusability. So if it is satisfying a particular or a stable user requirement, then it won't be able to work with flexible system and I can't use it for the general purpose. So it needs to be like reusability will be low. But when it comes to this object oriented, risk while using the analysis technique is low. So here risk will be low, flexibility will be more, so that reusability is also going to be high. Fine. Next. So in the structured or structuring requirements, that will going to include some of the designing methodology. What is that? DFT, data flow diagram, how data is moving. And also we have a structured English. So you can specify in a normal English language as a design part. And also we have a ER, entity relationship diagram, ERD. And also we have a CFD, that is control flow diagram. Based on the specification of a control, then we are going to do the diagram or a representation. Then we have a data dictionary, that's a repository, right? And also we have a decision table or a tree, and also we have a state transition diagram. So these are the design methodology which comes under structured analysis. And what we have in the object oriented, so the requirement engineering include, it will going to include the use case method. So here we are going to use the use case diagram. Based on the interaction to the user, we can develop this. And also it will going to use the use cases and flow of events and what are the activities it's taking place and the object model. So it will going to find the classes and class relationship, and also we have a object interaction, object to the year mapping, and also we have a state chart diagram. Along with that, we have a deployment diagram. So all these methodology will be used for the designing in the terms of object oriented analysis. And in this structured analysis, this technique is old and not preferred usually. So mainly like it's of going to work with a stable requirement. It is not so flexible. So it's of old and nowadays we are not using it. Fine. So then when it comes to the object oriented, this is what the trend now. This technique is new and it will be preferred. So when you wanted to design any of the software or a product or a system, then you can go with this object-oriented analysis. I hope you all understood my today's session. It's all about our today's session. In my coming session, we'll see the difference between structured and object-oriented design. Now we have learned its analysis. Then how it will going to be designed, we'll see in the coming session. Until that, keep learning, keep on growing. Thank you.